So greatest common factor notes. Factors are numbers that you blank together to get another number. What do you guys think? Multiply. So factors are numbers that you multiply together. So factors are numbers that you multiply to get another number. When you multiply two factors together, so let's say 2 and 8. I multiply the factors 2 and 8 together. So what's 2 times 8? What's 2 times 8?
16.
16. The answer is called the... So when you multiply two factors together, you get an answer. What's the answer called?
No, it's not. Gosh dang it. Greatest common?
Nope. Product. That's just... Okay. So a factor pair is blank numbers that you multiply to get a number. So a factor pair is two numbers that you multiply to get a number.
It's 2 numbers.
So a factor pair is two numbers that you multiply together to get a number. Okay. So here, list the factor pairs of 24. So, on your yellow note sheet, it says list the factor pairs of 24. So what can we all multiply together to get 24?
12 and 2.
Okay. Let's go in order. So I always try to, we can do 1 and 24, right? You said we can do 2 and 12.
Yeah.
Can I multiply 3 times anything to get to 24?
3 and 8.
3 and 8. Can I multiply 4 and anything?
4 and 6.
What about 5?
No.
Okay, then I go to 6. Well, I already have 6 here, right?
6 and 4.
So I'll basically be repeating. So those are my factor pairs of 24.
So we just write all this?
Yep, so just write all that down. So basically, if I take those two numbers, or those two factors, I multiply them together. Each time I multiply those together, I'll get the product of 24. Because 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. 3 times, so on.
You know we got these, right?
And I'm going to give you something else even better in just a moment.
We don't want no horror number.
You know she probably want to do this.
All right, so then example number 2. I want you to list the factor pairs of 36.
2 and 8.
So list the factor pairs of 36. I like to go in order, so the first one is going to be 1 and...
36.
What?
Okay. Then can I take 2 times something to get to 36?
2 and 18.
2 and 18. What about 3?
Where y'all getting this from?
Their multiplication. They are just that sharp. They're on it for now. Their multiplication tables.
3 and 12.
3 and 12. What about 4?
Yeah, 4 and 9.
What about 5?
No.
What about 6?
Yes.
6 and...
6.
Okay, so then we know anything. 7, 8, 9, and then at this point it's going to repeat, right?
Yes,
So once we have 6 and 6, it's going to repeat. 9 and 4 we already had. So how many factor pairs do they have here?
1, 2, 3, 4, 5.
Okay, so 5. So there's 5 factor pairs for 36. Make sure you have them down. We're going to do more with this.
So this is basically like what the...
This is just getting you thinking. Okay, so factors of a number are always what? So factors of a number are always blank than or equal to the number. So for example, when you did your factors of 36, all the factors of 36, so all those factors we found, 1 and 36, 2 and 18, 3 and 12, they were all what? All those factors were blank or equal to the number. Were any of them bigger than 36? No, so they are all less than or equal to the number. Because we did have 36 as one of our factors, right? But none of those factors went above that. A blank factor is a number that is a factor of every number in a particular group. What do you guys think is going to be filled in there? A blank factor
Common factor.
A common factor. So a common factor is a number. So common.
That was it.
Yeah.
Yeah.
So a common factor is a number that is a factor of every number in a particular group. And that's what we're going to be learning today. Common factors of 2, 3, or 4 numbers. So we're going to find the greatest common factor. Now, the way I look at it, when you're finding greatest common factors, it's something that they share. It's something that they both have, or they all 3 have. Okay? So, list all the common factors of 24 and 36. Now, we just did that already together. So what I want you guys to help me do here is put them in order. Okay? So, 24, because you guys have your notes in front of you. So 24, my factors were 1, 24, then what were they? 2 and 12, and then what?
3 and 8, and 4 and 6.
Okay? And then what were all my factors of 36?
1, 36, 2, 18, 3, 12, 4, 9, and 6, 6.
Okay? So now, what are the common numbers that they both share? Because common means they both have them. So what are my common factors that 24 and 36 both have? So what? Okay, so they both share 1.
2,
3,
Okay, they both share 2.
6.
They both have a 3.
Hold on, wait, doing too fast.
And they both have a 6. So those are the common factors. So 1, 2, 3, and 6. And what's another one? 12. 4. So they have a lot of common factors, right? So they have a lot of things in common. But that's not what we're learning today. We want to know what factors that they share, but we want to know what the greatest common factor is. And that's what we're going to be talking about here next.
Yeah, y'all don't think this
Okay.
is easy. It's hard.
We have it down. So looking at these numbers, so we have all the factors circled. What is the greatest common factor? What is the largest number that they have in common?
12.
Yeah, so the greatest common factor of 24 and 36 is 12. So the greatest common factor, 12. So the greatest common factor, what's a way that we can abbreviate the greatest common factor? GCF. So the greatest common factor is the largest of all the, what do you think? Well, not numbers. What are those numbers called? What was that number list? Common factors. For now, it's not going to help you. You'll definitely want the abbreviation down because you don't want to have to write greatest common factor every single time. You'll want to abbreviate GCF. So underneath that there it says example 4, what is the greatest common factor of 24 and 36? You guys already determined that it was 12. So writing underneath example 4, you're going to put greatest common factor equals 12. Under example number 4. It's up on the board, kiddo. Did I? Did I say example 12?
Yes, you did.
How would you know with your head laying back on that desk and drool coming out of the side of your mouth? You were listening to me? Somewhat. Okay, so now let's talk about how we find the greatest common factor. So one way to find the greatest common factor of 2 numbers is to list all of the what? What do you guys think? Read through there. Think about it. Stop and think. One way to find the greatest common factor of 2 numbers is to list all of the blank blank of each number and pick the blank number that is a factor of both numbers. What do you think?
I don't know, because every time I guess I get it wrong.
I'm going to say greatest common factor again.
No, common factor.
Okay. How about factor pairs? So you're close.
Right.
of each number and pick the blank number that is a factor of both numbers. What are we trying to find? The greatest. So that's one way that we could do it. So one way we can do it is just how we did it at the very beginning here. Except for if we're dealing with super large numbers, that could take, like let's say I gave you the number 1,000. Think how long it would take you to list all the factor pairs of 1,000.
5,000 years.
It would take you a really long time. So that's not going to be ideal for when you're working with larger numbers. So the way that we're going to do it is by 3 simple steps. Now, I'm even going to make it easier than that in just a moment. So step 1. So when working with large numbers and variables, it is much easier to do it another way. So step 1, write the prime factorization of each number. This is going to come back from first semester. To write the prime factorization of each number, you need to make a factor tree. That's right. So factor tree.
I know this because I already took this class last year.
She's an old one. Okay, so that's step 1. Step 2 then, after you make your factor tree, you're going to circle every factor that appears in both lists. I don't like to fill in the blank without a word bank. So it's all right. If you guess wrong, it's a guess. So then step 3, write out the list of factors that appear in both lists and blank them together. What do you think you're going to do?
Please.
Circle.
Factor. Factor means, factor goes with what operation? So write out the list of factors that appear in both lists and multiply them together.
You guys learn this again.
Hey, you know what? I like that you're answering, Sinisha, even though you're not getting them right, because it shows me that you're at least thinking. You're trying to get it.
It feels like
that's
us
okay.
two were saying the most answers
I don't
on
know.
this time.
Answers, I don't even got it right.
That's all right. Okay, so make sure you guys have these down. So look at example number 5 now. It's at the very bottom. You guys are going to have to, example number 5 is at the very bottom of your page. So you're going to have to squeeze it in. So now we're going to, I know you guys already understand what the factors are of 24 and 36, but now we're going to follow steps 1 through 3 to determine what they are. So we're going to do a factor tree of 24 and a factor tree of 36. So you're going to have to write kind of small to get all under there. So 24, we're going to do my first factor tree. What times what? What 2 factors can I multiply together to get 24? Raise your hand, please. Sinisha. So I'm going to use 2 and 12. Now, when I am making my factor tree, I am going to circle my prime factor. 2 is a prime factor. Why is 2 a prime factor? Raise your hand if you can tell me why. Nico. You can't break it down anymore. I mean, you could keep saying 1 times 2, 1 times 2, 1 times 2, but that's redundant. We don't need to do that. So you can't break it down. It only has 2 factors, 1 and that number itself. 12, is it prime or composite? Raise your hand. Why is it composite, Vernell? Raise your hand if you can help him. Kijan? I just didn't hear you.
You can reduce it down.
You can reduce it down, meaning it has more than 2 factors. So what are 2 factors of 12?
2 and 6.
So 2 and 6, we already determined that 2 was prime. 6, what are 2 factors of 6, Paige? 2 is prime, and 3 is prime. Okay, so now I'm going to make a factor tree of, I'm going to do it in a different color just in case I get too close, of 36. What are 2 factors of 36, Zach?
36.
What 2 numbers can you multiply together to get 36? Don't shrug your shoulders. Look at your notes. We already found factors. So give me 2 factors of 36. You said 3 and 2 and 18, you mean?
Yeah.
Okay. 2 is prime. I'm going to circle it. What are 2 factors of 18, Nico?
4 and 6.
For 18?
I don't know.
If you have your multiplication sheets, those will help you. Dylan? 9 and 2. So 2 and 9. All right. What are 2 factors of 9? Cheyenne?
This is double 5.
Cheyenne, what are 2 factors of 9? What 2 numbers can I multiply together to get 9? Okay, what else can I do besides 1 and 9? Cheyenne, you sound so manly. What do we have? You're right. Okay. Help her out, Nico. 3 and 3. And these are what type of numbers, Nico? So, okay. So what you guys have done on your notes here, we wrote the prime factors of each number by making a factor tree. So now what we're going to do, we're going to make a list. Okay? We're going to make a list. So what I'm going to come down, I'm going to write 24 equals, and I'm going to write 36 equals. I'm going to write all of my prime factors that I circled. Now remember, I'm going to write them in order from least to greatest right next to 24. So I'm going to write out 2 times 2 times 2 times 3. Okay? Then I'm going to write out all my prime factors of 36, which is 2 times 2 times 3 times 3. So I made my list. So as Tijan just said, now we're going to circle every factor that appears in both lists. So 24 and 36 shares a factor of 2. Okay, so I'm going to circle those. Okay. They also share another factor of 2. So I'm going to circle those 2 together. Do they share any other factors? 3. So I'm going to circle those 2 together. Now you can circle those 2 together, or you can circle these 2 together. It doesn't matter as long as you circle a pair of 3s. So that was my step 2. Step 3 says write out the list of factors that appear in both lists and multiply them together. So I'm going to drop down. I'm going to put greatest common factor.
So, I got a question.
Yes.
So, would you do like 2 times 2 times 2 times 2?
No.
And then 3 times 2?
No, because they're a pair, right? So I'm going to take the one pair and drop down and write a single 2 for it. Then I'm going to drop down and write a single 2 for it, because they go together. They're common. And then I'm going to drop down and write a single 3. So they share a 2, they share another 2, and they share a 3. So step 3 said write out the list of factors that appear in both, and then now we're going to multiply those together. So what's 2 times 2 times 3? Okay, so 2 times 2 is 4, 4 times 3 is 12. So the greatest common factor is going to be 12.
I got some different.
What did you?
Because you circled, you wrote the wrong factors out. So what are the factors of 24? 2 times 2 times 2.
I had to use what y'all use?
Yeah, we're looking.
No, you don't have to use what I use, but you made a mistake. 3 times 6 is going to be 18. That should have been 2. So it was just an error. Hey, for now, you're going to need to keep that hood down. Okay, so flip your papers over when you're done with that. And let's take a look at example number 6. So now I want you to find the greatest common factor of 50 and 60. So flip your paper over. Flip your paper over and start doing factor trees for 50 and 60. Come on. Come on, Dylan.
Are we doing the factor tree on this?
Yes. So we're going to follow the 3 steps that were outlined.
Wait, how do you have 50s on here?
Hey, Maya, you got to limit your talk outs, girl. So we're going to do our factor trees. Mm-hmm.
By this part.
5 is prime, yes. Okay. So for the sake of time, let's go ahead and get going. Factors of 50. Dylan, do the factor tree of 50 for me.
5 and 10. The 10 is 5 and 2. So figure 2 and 5.
Okay, 60, Paige. Sorry, you're writing. Raise your hand if you can do 60 for me. Tanisha.
5, is it 5 times? No.
We can't do it from right here.
Yeah, you can do it.
6
6 and 10. Okay, keep going.
and 2. Yeah, 6 is 5 and 2. Then next one, 6. We're gonna do 3.
Okay. So that's step 1. Now, step 2, I'm going to make my list. So I'm going to come with 50 and 60. So I'm going to write my prime factors of 50. So my prime factors of 50 are what, Paige?
2, 5, and 5.
Okay. What are my prime factors of 60? Kijan, what are my prime factors of 60?
5 times.
Always go in order, least to greatest.
2 times 2 times 3 times 5.
Okay. So step 2 now tells me I need to circle the prime factors or the factors that they share or that they have in common. So what numbers or what factors do they have in common here?
2,
So I'm going to circle a group of 2s and a group of 5s. So that would be step 2. I circled the factors that they have in common. So now I'm going to drop down. I'm going to write greatest common factor. And I'm going to list the factors that they share. So they share a factor of 2 and a factor of 5. And what do I do with these two numbers now according to step 3, Amaya? What do I do with those two numbers? The two common factors.
Multiply them together.
So 2 times 5 is? So the greatest common factor of 50 and 60 is 10. Okay? You got a question? Yes.
Wait, what if you circle the 2 5s up top?
It doesn't matter because you're still going to have one group of 5s, right?
I did that.
So like what she's asking, let's say, I'm going to circle in pink. Let's say that she circled, are you saying this 5 with this 5?
No, like
Oh,
the 2
you
5s.
can't circle those two. Why can't you circle those two?
They're in the same line.
Yeah, they're in the same line. 50 and 60 don't share those 5s together. You have to circle what they have in common, what they share.
Okay.
Okay? Because you're trying to find what everything has in common. Like if, what can I use as an example here?
Everybody has leaves.
Laney.
I'm gonna leave.
Paige, stand up. Okay. So you have 2 individuals here, right? What do we have in common? What do Paige and I have in common? What do we both share?
Hair.
Oh.
Okay, we both have hair. We have that in common.
Yeah,
What? He said both.
We're both females, so that we have that in common.
Same colors.
Do you have
Same.
tattoos?
No.
No tattoos. So that wouldn't be something we have in
Oh,
common.
same race, like same color.
We're the same color, so we have that in common.
Same height.
We're pretty much the same height, so we have that in common. So we have those things in common, so they go together. What don't we have in common, though? What are our differences?
Hair.
Hair color. So we wouldn't circle that together because that's different, okay? What else do we have in common?
And you got tattoos.
I have a tattoo, she doesn't.
You
A
got
tattoo.
glasses, you don't.
She has, okay, so those are things that we don't share, so we wouldn't group them together. We only group together what we have in common.
What color is that shirt you got on? It's like a blue.
Like a turquoise.
Yeah.
It's like
A green, mint green, I don't know. Okay, so you're only circling what the two things have in common. All right. This is where it's going to get fun. What did I throw in here?
Oh my God.
Variables. But because I'm throwing something else at you, I'm going to give you a bit of a cheat sheet.
Man, we need one.
Yay.
thing.
That's a long sheet.
So take a minute. Look at what I'm passing out to you. Take a look at what I'm passing out to you. It says prime factorizations. I am giving you the prime factors for each number. However, I'm going to put it in with the multiplication charts, okay? However, it only goes up to the number 99. So any number that's larger than 99, you will still have to do the factor tree for, okay? Anything under 99 is listed on there. But like, let's say I say the number 39, not 39. Let's say I say the number 17. I want you to find the greatest common factor, or I want you to find the prime factors for the number 17. Is 17 on there?
No.
Why not?
Because,
You can't do anything to it because it is a prime number, okay? So any number below 99 that is not on that list, it's not on there because it's already a prime number.
1, 2,
Okay,
3.
so how we're going to make this a little bit easier on you guys is the number 20 on your list.
Yeah.
Is the number 45 on your list.
Yes.
So we can skip step 1. We don't need to make the factor trees. So what we're going to do instead, we're going to skip right to step 2. So we're going to write out 20 and we're going to write out 45. So look at your list. What are your factors for 20? So Kijan, what are your factors of 20?
2 times 11.
Look at 20. It says 20 equals. What are your factors of 20?
2 times 2 times 6, 5.
Okay? So instead of doing the factor tree to get all of our prime factors, I gave you the prime factorization chart.
Thank you.
So now look at 45. You're welcome. So now look at 45 on your list. What are your prime factors of 45?
3, 3, 5.
So 3 times 3 times 5. So step 2 says write out my prime factors and circle the ones that they have in common. So what do both 20 and 45 have in common? 5. So I'm going to drop down for step 3. I'm going to put greatest common factor. What's the number that I circled?
5 times 5.
Just one single 5 because that's what they share. They share one 5.
Okay.
Okay. Well, there's not another number to multiply it by, is there? There's not another one, so I can't multiply it. But now I have variables. What variables go with 20?
X, Y.
Okay, so I'm going to go ahead and put times x times y. What variables go with 45?
Y, S. I mean, Y, Z.
Where you see that?
So top.
No, I'm talking about on the paper.
It's right at the top. So now looking, I can't just say the greatest common factor of 20xy and 45yz is 5 because they also have some variables in common. So look here. Do they both have an x in common?
No.
Do they both have a y in common?
Yeah.
So I will go ahead and circle my y's.
So it's Y.
Do they have a z in common? No. So they also share a y. So the greatest common factor for these numbers is going to be 5y.
I thought we were going to use 5, Y.
Look, you know what you do? You should just give us the worksheet and do this tomorrow.
No.
Man.
Okay, hey guys, watch the talkouts, please. Okay. So let's take a look at example number 8. Yeah, okay. So example number 8, if you guys are waiting. You ready? Dylan, you ready? Okay, so example number 8, the first, oh, this is easy. Now I'm going to go back and give you something easy.
15 and 14.
15 and 14. So 15 and 14 are both going to be on your prime factorization sheet. So we can skip step 1. We don't need to make a prime factorization tree. We don't need to make a factor tree. Zach, what are my factors, my prime factors of 15? What are they for 14?
2 and 7.
Okay, so step 2, I listed out my prime factors. Now I need to circle what they have in common. Well, 15 and 14. Oh, tell Mr. Alberter his Thomas looks like an R. I thought it was Ramus. All right, thank you. Okay, so they don't have a number in common that we have listed. But with that said, every single number has a common factor of
2 or
1. Because really 15, what's another factor of 15? 1 and 15. What's another factor of 14? 1 and 14. So if you run into a circumstance like this, where they have nothing in common, we know that every single number has a common factor of 1. So your greatest common factor
One.
is 1.
One apple.
I will tell you, on your worksheet today, you will have, I know at least one answer where the greatest common factor is 1.
How much is it per pass?
What's that?
How much is it per pass?
I'm not going to let you use a pass during the middle of notes. Okay. All right. Now, when we're finding greatest common factors with variables, because you are going to have variables, and those variables are going to have exponents. So when using variables with exponents, use the blank exponent for that variable and the greatest common factor. So I'm trying to think how I can explain it to you. So let's say you have, let's just look here. Let's say they all have a variable of x, x3, and x4. So there's x squared, x3, x4. They all have a what in common? The variable x. How many of those x's do they all have in common, though? How many do they all share? 2. You're going to choose the variable with the smallest exponent, okay? So smallest or least.
Do we write the X part now?
You don't. You don't. So use the one with the smallest exponent as part of your
Where's that
answer.
at?
Under example number 9. Sorry, the notes kind of went out of order here. We're going to come back to example 9. I'll give you those two numbers in a moment. But under example number 9, where it has that bolded point, when using variables, plug in smallest. You have that, Nico? Can you set it for me? You're not going to put smallest on your number line. You're going to drop it down and put it underneath there.
Oh, we gotta put it underneath.
No, you're good for now. I checked. Okay. So example number 9. This is your two numbers you're going to plug in onto your example lines. It's 75x squared y cubed. 30x cubed and y to the 5th. Because we have our cheat sheets, we do not need to write out our factor trees. Okay? Because we have our cheat sheet, we do not need to write out our factor trees. So on your notes, I want to see you guys writing the factors, the prime factors for 70 and the prime factors for 30. You need to write your 2 example problems down. You need to keep up with me.
I have a question. What's y to the 5th power? Like, what is that?
Just y to the 5th. That's just how you say it, y to the 5th. It's not like y squared.
S.
There's no special way of saying it. I want to see you writing out your factor pairs. Or sorry, not your factor pairs, your prime factors. I want to see you writing out your prime factors. Use your cheat sheet. Okay. So when I refer to my prime factorization sheet, the prime factors for 75 were 3 times 5 times 5. My prime factors for 30 were 2 times 3 times 5. So to continue on at step 2, after I had listed out my prime factors, I need to circle what they have in common. So what do they both have in common here?
They just had a 5.
5. So you can either circle them like that, or you can circle them like that. But you cannot circle like that in the purple, okay? So, instead of writing x and y with my 75, we're going to use our shortcut.
Didn't you use 3?
No.
Oh, very good, Nico. I have common factors of 3 as well. So when I drop down to do step 3, I'm going to write greatest common factor, and I'm going to list the 2 common factors that they share. Nico, you said they share a 3 and they share a 5. We're going to multiply those 2 factors together. So what's 3 times 5, anybody? 15. Now here's the fun part. We're going to look at our exponents. So I look at my first number with the exponent. It has an x. I look at my second number. Does it have an x as well? Yes. So this is where we're going to use the notes that we took. It says, when using variables with exponents, use the smallest exponent that variable has. So x squared or x to the third? Which one's smaller? So the greatest common factor, I'm going to drop down and put x squared. So I come back up and look at my next variable, a y. Does my 30 have a y? Yes. So I'm going to use the variable with the smallest exponent. What's my smallest exponent?
X to the power.
You mean y?
You know.
You can say y to the third. So that's going to be the greatest common factor.
We don't put nothing in between them?
Nope.
I thought we did.
Nope, it's just 15x squared y to the third. Do you guys understand how that works?
Yeah.
So you don't write what I'm writing in red right now, or actually I'll do it in pink. So I'm going to write out the variables for 75. So how many x's do I have? How many y's do I have? 1, 2, 3. Okay, and now for 30, how many x's do I have?
Wait, what?
3,
And now how many y's do I have?
5.
1, 2, 3, 4. That's a lot of extra work, right? So no, I said you don't have to write what I write in pink. Now, what do they share? They share a group of x's here, a group of x's here. Do they share any other x's? Okay, they share a group of y, a group of y, and a group of y. So if I would write the greatest common factor of just the variables, how many x's do I have?
1,
How many groups of x's do I have?
2,
So x squared. How many y's do I have?
3.
So this here is basically the same as this. It just is a shortcut. So if you want to write all these out, you can, but I would recommend using the shortcut. Okay, let's take a look at example number 10. So now we're going to deal with 3 numbers. We're going to follow the exact same steps of what we've done already, but now you have 3 numbers. So 36, 72, and 99. So find the greatest common factor of 36, 72, and 99. Cheyenne, can you write that down for me? Use your prime factorization sheet to write the factors out for each of these numbers. Good, Paige. All right, Vanessa, start writing out your prime factors. Make your list. So you can skip right on down to step 2 and make your list.
Pencil jam.
Excuse
I
me.
already got another one. I just.
Okay. All right, Tanisha, what are my prime factors for 36?
2.
Okay,
2, 3, 3.
so 2 times 3 times 3? Are you sure?
No, I said 2,
2,
2.
2, 3, 3.
Oh. All right, Vernell, what are my prime factors for 72?
2, 2, 2, 3, 3, 2.
So I have 3 of each.
3 2s and 2 3.
Is that right, what I have now?
3 2s, 2 3.
Okay, so I can get rid of that. And then what are my prime factors for 99, Paige?
3, 11.
Okay, so I made my list. Step 2, from my list, I now need to circle my... What do I need to circle? The factors they have in common. So what factors do they have in common here?
All 3s.
3. So this is going to be a crazy looking circle, okay? They only share 1 3, right?
No, 2.
Oh, so I am going to have to do some crazy circling.
Okay, you just like put them all together since they all like.
Or you could maybe do it like this, underline them.
My,
Or you can just do crazy circles like me.
Because that started to look like a
So I'm going to drop down. I'm going to write greatest common factor. What are the factors that they share? 3 times 3, right? Because we had 2 3s that we circled. We're going to multiply those together. What's 3 times 3? 9. So what's the greatest common factor of 36, 72, and 99? 9. And we're going to stop there. We'll do the last one tomorrow.
Yay.
Make sure you have all of your notes. Do not lose this blue sheet, because guess what? I'm going to let you use that blue sheet on your what? Test and quizzes.